This answer is fluent. It's confident. It even cites a source. And it's wrong. The contract renews on the 14th, not the 20th. From the answer alone, you can't tell what broke. Welcome to AI Tech Book. Today, how to evaluate a RAG system. So the score tells you not just that the answer is wrong, but exactly which layer to fix. Here's the reframe. A RAG answer can fail two completely independent ways. 1. Retrieval. The right document was never pulled, or it was pulled but ranked so low the model barely used it. 2. Generation. The right document was retrieved, sitting right there in the context, and the model ignored it, contradicted it, or made something up anyway. A single end-to-end score blends those together. 6 out of 10 tells you the answer is mediocre. It does not tell you whether to fix your retriever or your prompt, so you measure the two stages separately. Start with retrieval. On the retrieval side, 2 questions. First, are the chunks you pulled relevant and ranked near the top? That's context precision. A retriever that buries the right chunk at position 9 scores badly, even though it technically found it. Second, of all the chunks you needed, how many did you actually pull? That's context recall. Miss one, and the model is answering with a hole in its context. When order matters, 2 classic metrics sharpen this. MRR mean reciprocal rank, rewards getting one good result near the top. And NDCG scores graded relevance, weighted by position. Precision and recall tell you if retrieval is healthy, MRR and NDCG, how well it's ordered. But say retrieval is perfect, can the answer still be wrong? Yes, which brings us to the most important metric in RAG, faithfulness. Faithfulness, also called groundedness, is the fraction of claims in the answer that are actually supported by the retrieved context. It's the anti-hallucination metric. And it is not string matching. You decompose the answer into individual claims, then check each one for entailment against the context. Take the worked example. The answer says the contract renews on the 20th of March and auto-renews for 12 months. 2 claims. The context supports the 12-month renewal, but it says the 14th, not the 20th. 1 claim supported, 1 contradicted. Faithfulness is 1/2, 0.5. That low score is your hallucination signal. The model asserted something the context never supported. But does faithfulness check that the answer is on topic? No, for that, 2 more metrics. Answer relevance asks, does the answer actually address the question? An answer can be perfectly grounded and still wander off into something you didn't ask. One way to estimate it: reverse the problem. Generate the questions this answer would fit and see how close they land to the real one. Then citation accuracy, and this is its own thing. Citation recall is every claim backed by a passage you actually cited. Citation precision, are the passages you cited actually relevant? A model can be faithful to its context and still cite the wrong lines, so you score citations separately. But all of these need a grader. Who decides supported? Increasingly, another model, an LLM-as-judge. It reads the context and the answer and decides, claim by claim, whether each is supported. The single most important design choice, and Anthropic calls this out, is to force a discrete verdict. Don't ask the judge for a paragraph of vibes. The answer is mostly reasonable, but you can't average that. Give it a rubric and a fixed output, supported or not supported, or a 1 to 5 scale. Now every grade is a number, the metric aggregates. You can compare 2 versions of your system and see which one actually moved. But can you trust the judge? Not blindly. An LLM judge has measurable biases. Position bias, show it 2 answers, and it tends to prefer whichever came first. Verbosity bias, it rewards the longer answer, even when it's not better. Self-preference bias, it rates outputs in its own style higher. None of that makes judges useless. It means you engineer around them. Swap the order and average. Write an explicit rubric instead of which is better. Ensemble several judges. And above all, calibrate against a small set of human labeled examples. So you know how far off it runs before you trust its numbers. Calibrate against what, exactly? Against a golden set questions, each with a reference answer and the context that should support it. Some metrics can't work without it. Context recall has to know the full set of right chunks. Correctness needs a right answer to compare to. Those are reference-based, and the gold is real annotation cost. But faithfulness, answer relevance, the whole RAG triad, those are reference-free. They score from only the question, the context, and the answer, so they scale with no labels. And if you need gold but can't afford thousands of labels, RAGAS showed the middle path, synthetic queries from your own corpus, fine-tuned judges, anchored with a few hundred human labels. So how do these numbers tell you what to fix? By reading two of them together. This is the payoff. Put faithfulness next to context recall. Low faithfulness but high recall. The context was there, the model just didn't ground its answer in it. That's a generation problem. Fix the prompt. Low faithfulness and low recall. The context was never retrieved. That's a retrieval problem. Fix your chunking, your embeddings, your retriever. Same wrong answer, two different fixes, and the metrics tell you which. RAGAS, Trulens, Evals, and Arise Phoenix all run this in your pipeline. The whole evil on one screen. Split retrieval from generation, two independent failures. Retrieve, precision, recall, MRR, and NDCG. Ground, faithfulness, claims supported by context, the anti-hallucination metric. Judge, an LLM forced to a discrete verdict, debiased and calibrated. Localize, faithfulness against recall points you at the layer to fix. That's RG Evals, measure both layers separately so the score localizes the fault. If this helped, subscribe to AI Tech Book. Next time, prompt injection when the input itself is the attack.